Hello class, welcome to this video on the AP Stats 6.1 to 6.2 quiz. On the lessons, it's referred to as 6.1 to 6.4. However, on your textbook, it's 6.1 to 6.2. So let's go over the practice quiz. So number one, it says a certain length of a busy road has 3 stoplights. Okay, so a certain length of a busy road has 3 stoplights. The probability distribution of the number of times a driver encounters a red light on this length of a busy road is shown in the table. Based on the probability distribution, what are the approximate mean and standard deviation of the number of red lights a driver encounters on this length of a busy road? All right, so we want the mean and standard deviation. So you could do this on your calculator, but you would also want to show your work. So on a sheet of paper. So remember the formula to calculate the mean of a random variable. So let's say that x is the random variable for the number of red lights. So then in this case, mu x is going to be, so the formula for that is the sum of x of xi times the probability of that x value. So basically you take each of the red light values and you multiply by the probability of the red light values. So in this case, we got 0 red lights is a 0.04 chance to happen, and then you keep adding this. And the last red light, the number of red lights is 3, and that's a 0.46 chance of happening. Okay, so that's how you calculate the mean, and of course you can get it on the calculator. We'll do that on the we'll show you that on the graphing calculator, so you know how to do that. And then we have the standard deviation. So the formula for the standard deviation is the square root of the sum of xi minus the mu x squared times the probability of that x value. All right, so we got the square root. Now we need to figure out the mu, so we're going to figure this out here and to see what we get. So it turns out that the mu, when you do it, is 2.2, around there. So then if I use that value here, I get 0 minus 2.2 squared, so that's the x value of 0 minus 2.2, times the probability of that is 0.04. plus dot 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 all the way to, and then the last x value is 3 minus 2.2 squared times the probability of 0.46. Okay, and then when we do that, we should get a value of around 0.87. So let's plug this into the calculator and see if we can maybe we can get those values. Let's do this on the calculator. Okay, so I got the calculator out and we can go ahead and plug in the value. So first you're going to need to go to stat, and then we want to go to edit, and then we're going to, well, I'm going to delete all these values because I don't need any of these values. Okay. All right, the first list is going to be x. So we got 0 red lights, we got 1, 2, and 3 red lights. And then here we got 0.04 for the probability. Like 18, 32, and 46. Okay, so we got our list together, so we can then we go back to stat, and then we go to calculate, and we go to 1var stats, so number 1. And remember, if you don't have this menu, you're gonna just hit L1, comma L2. But here I got this version, so I just put list 1, and then I'm gonna do list 2. So second, stat, and then list 2. All right, and calculate. But you can see, like, if I go, I wonder if it'll take me up. It won't let me. I don't think it'll let me. But yeah, so you put, if you don't have the menu, you just put 1var stats, like, you know, normal, and then you put list 1, comma, the comma key is there, and then list 2. But yeah, here's your value. So x bar is your mu, 2.2, and then your sigma is 0.87. That's exactly what we end up getting. All right, so here we go. So we got the answer. So the answer has to be D. All right, so number 2, a charity in San Diego plans to sell 50,000 tickets for their charity fundraiser at $100 a ticket. From the tickets sold, one ticket will be randomly selected and its owner will win $1 million. The expected value for the net gain for each ticket is negative 80. So they're expected to lose $80 on average after many, many times. What is the meaning of this expected value? Okay, so that's exactly what they're talking about. So in this case, based on what I was saying, after many, many times, right, of many, many tickets randomly selected, we would expect to lose an average of $80. So it says the ticket owners lose an average of $20 per ticket. No, that's $80. Ticket owner loses an average of $80 per ticket. That sounds right. They won't win. They would have to purchase 80 more tickets for the expected values to increase to 100. No, that's not correct. So the answer is B. On average of $80 per ticket. Again, after you do this many, many times. A newborn baby is categorized as low birth weight if the baby weighs less than 2,500 grams, 5 pounds, 8 ounces. The distribution of weights for newborn babies is approximately normal, with a mean of 3,300 grams and standard deviation of 375 grams. Which of the following is closest to the probability that a randomly selected newborn baby will not be categorized as low birth weight? This is will not be categorized. Okay, so all right, so first off, we want to draw the normal distribution. It says the mean is 3,300, so we got mu x is 3,300. We got our sigma x is 375. So just to show our work, we're going to draw the normal distribution. All right, and then we're going to go by 375s, right? So we're going to add 375, to get the next values. Okay, so we got 3675, 4,050, and then 4425, and then we're going to subtract. Okay, so we got all those values there. All right, and it says, which of the following is closest to the probability that it will not be categorized as low birth weight? Okay, and it says it's less than 2,500 grams. So that means we're like over here. So we want the probability that it's less than that. Oh, it says it will not be categorized. Okay, so not. So key is not. Okay, so it will, this is 25, it will not, so that means it's the area to the right. Oops, wrong color. Okay, so we want this part. All right, so we're gonna convert this to a z-score, the 2,500. So remember the formula for the z-score is x minus mu divided by the sigma. So the x value is 2,500 minus the mean. Divide that by the standard deviation, which was 375, I believe. See what we get for that. Remember, put that in parentheses and if you're doing that on the calculator, the numerator. So you get negative 2.13. All right, so now we're going to look up this value, negative 2.13. So we're going to go in our table of values, negative 2.13, and see if we can find it. So negative, it's negative 1.4. See if we can find, oh, we need some, I need the other page. Okay. All right, so we got negative 2.13. Okay, so this is negative 2.1, and then 3. So then that looks like this value right here. So 0.0166. So 0.166. Remember, this is the area to the left, right? So to get the area to the right, I got to do 1 minus that. Okay, so that's what I'm going to do. Okay, 1 minus 0.0166. All right, so then 1 minus 0.0166 is 0.9834. So that's this work right here. I forgot to put it on there. So yeah, so 98.34% or 98, so around there. So looks like the answer is C. But we're going to show you how to do this on the calculator as well. So remember, you're going to use normal CDF. Then you're going to type in lower. The lower value here is, well, remember, you're going from 2,500 and on, right? So your lower is 2,500. Your upper is basically infinity because it's from here on, right? So it's going to be big, a really big number. So like 10 to the 9th power or something like that, some big number. And then your mean is 3,300. Your standard deviation, we said, was 375. So this is what we're going to plug in. You can plug in whatever big number you want, but 10 to the 9th power, 9 zeros, you know, this is a big number. We're going to do that on the calculator. Okay, so let's do that on the calculator. So we got, we're going to hit second and then vars. Then we're going to go to normal CDF. Our lower, forgot what our lower was. Our lower was 2,500. And then our upper is 10 to the 9th power, or a really big number. Just insert a really big number. 10 to the 9th power is big. The mu was 3,300. And then this was 375. Okay. And then again, if this menu doesn't pop up, just literally type 2,500, comma, 10 to the 9th, comma, 3,300, comma, 375. It'll look like this basically when you do it on the regular menu with commas. That's what you're gonna have to put. So yeah, 0.9836. That's really close to what we got. Okay, so then we get 0.9386, which is really which is that. Okay. All right. So number 4, random variable A is right skewed with a mean of 2 and a standard deviation of 10. The random variable B is defined by B equals 1 plus 3A. What are the mean and standard deviation of B? Okay. So we said that they said that the mean of A is 2 and the standard deviation of A is 10. So then, and they said that B is 1 plus 3A. So to do the mu of B, that's the mu of 1 plus 3A, right? Now remember, you can if you use addition, if you add, here you're adding 1, right? So if you add 1 to the mean or to each of the values, that's going to influence the mean, okay? So the mean of 1 plus 3A is equal to, so if I add, right? So if I add 1, that means I'm going to have to add 1 to the mean, okay? So it's going to be 1 plus the mean of 3A. But then what's the mean of 3A? Well, you can, if you're multiplying by 3, then that means you're going to multiply, if you're multiplying everything in A by 3, then that means that the mean is multiplied by 3. So it's 1 plus 3 mu A, okay? All right, so there you go. So in other words, there's your formula. So we got 1 plus 3 times 2. Mu A is 2, right? So it's going to be 7. Okay, so that one, it's either C or D for that one, right? So it's either C or D. So now let's do the standard deviation. So sigma of B is equal to sigma of 1 plus 3A. Now, 1 does not influence the standard deviation. The 1 doesn't do anything to it, okay? So if you add or subtract, it's not going to influence the spread. The only thing that's going to happen is that it's going to be influenced by the 3A. Okay, so if you multiply by 3, that's going to multiply the spread by 3. So in other words, it's just 3 times sigma A, but A, the standard deviation for A was 10, so it's going to be 30. All right, so there you go. You got 7 and 30 for your mean and your spread. So it's got to be D. All right. All right, number 5. A business person's commute from their home to work consists of walking to the bus stop, riding the bus, and then taking the train. The mean and standard deviation for the distribution in minutes for each segment of the commute are shown in the table. So you got your table here, your mean and your standard deviation for walking, riding bus, and taking the train. The total time spent walking, riding the bus, and taking the train are mutually independent. So that's important that they're independent. The total travel time from home to work consists of the total time spent walking, riding the bus, and taking the train. So you got to basically combine those two to get the total time from home to work. What are the mean and standard deviation of the total travel time? Okay, so let's just call this A, B, C. Okay, so the mu for work, right? Or like I said, we'll say mu T for total, the total time, is equal to mu A plus B plus C. So that means if you're doing A plus B plus C, that's just the average of each of them added together. Okay, and then the standard deviation for the total time. So standard deviation of A plus B plus C. Remember that when you're adding the standard deviations, you actually can't add the standard deviations directly. When you're adding, 2 or more variables together, it doesn't combine the standard deviations. What it does is it combines the variances. So you can do the sum of the variances. So the sum of the variance for A, the sum of the variance for B, and the sum of the variance for C. That's how you combine variances. You can just do that. And so that means that the standard deviation is the square root of those sums. Okay. So it's the Pythagorean sum of those three things. All right. So that's how you do it. So mu A, they said that the mean was 5. So 5, 30, and 40. So 5 plus 30 plus 40, that's 75. And for this one, and the standard deviations are 2, 5, and 6. So square root 2 squared plus 5 squared plus 6 squared. All right, and that's how we do that. So square root of 4 plus 25 plus 36. So square root of, so we got 29 plus 36. So that's 65. And so let's calculate that. So 8 times 8 is 64. So it's going to be pretty close. Oops. It's going to be pretty close to 8 and some change. So 8 point something, 8.1-ish. So about 8.06 or 8.1 minutes, approximately, if I round it to the nearest tenth. Oh yeah, they got 8.06. So let's do that, 8.06 to the nearest hundredth. Okay, so 8.06 minutes for the standard deviation, and then 75 minutes for the average time. So the answer has to be C. Okay, so just be careful with standard deviations. The means you can add together. You cannot add standard deviations together. You can only add variances together. And so to do the standard deviation, you can take the square root of the sum of the variances. All right, so number 6, the attendance clerk at a large high school is responsible for tracking the number of days each week each student is absent from school. Let X equals the number of days absent in a week for a randomly selected student. The probability distribution of X is shown in the table below. So is X discrete or continuous? Well, notice that it goes from 0 to 1 to 2 to 3 to 4 to 5. They're whole numbers, right? So that's discrete. So here for A, it's discrete. Because the clerk records whole number of days. Absent. So in other words, it's countable. All right. Part B find the probability that a randomly selected student is absent at most 2 days. At most means less than or equal to 2. All right, so we want the probability that little x is equal to 2. All right, so remember, we just want, or less than or equal to 2. that means that it's equal to, it could be equal to 2, it could be equal to 1, or it could be equal to 0. And so we just add those together. 2, 1, 0. So 68, 17, and 10. All right, those are the probabilities from the table for there. Okay, and we add those together and we get 95%. Okay. It says part C, find the expected number of days absent in a week. So expected, that's mu, okay? So this is part B. Let's do part C over here. Mu x is equal to, and this is capital X, in a week. So the expected number of days absent in a week for a randomly selected student. So again, we're going to use the formula, the sum of the little x values times the probability of the little x values. Okay, so you take each of the values, 0 times its probability, 0.68, and you add them together, all the way to 5 times 0.01. And then, of course, I showed you how to do it on the calculator. So if you do this, you're going to get 0.55 days. Okay, so that's for part C. Part D, find the standard deviation of x. So let's do that over here. Sigma x equals square root, and this is the big X, of little x minus, sorry, I need to write down the formula. So the sum of the x value minus the mu squared times the probability. All right, so we got to subtract the x value. So the first x value is 0 minus the mean was 0.55 squared times the probability of 0.68 plus dot dot dot. Then we got 5 minus 0.55 squared times 0.01. Okay, I guess we're going to do that on the calculator. You get 0.973 days. Okay, so that takes care of part D. Again, try to show your work even if you're going to use a calculator. E, describe the distribution of x. Okay, so when they say describe it, they basically want you to describe the center, the spread, right? They want you to describe the shape, that kind of stuff. We already know what the mean and then the standard deviation is. However, let's go ahead and find the median. Remember, to find the median of a probability distribution, you basically have to keep adding the probabilities until you get to 50%, 0.50. Once you get 0.50 or higher, then that particular x value is your median. Notice that if I go here, I'm already at 50%, right? 68%. So therefore, my median is 0. Okay, so that means that my median, notice that my mean, which is 0.55, is greater than my median, which is 0. So if the mean is bigger than the median, well, that's telling you that it's skewed right. So that's one way to tell. If it's less than, it's skewed left. If it's equal to or approximately, it's approximately symmetric. So this is a good way to tell. So therefore, it has to be skewed right. You can also graph this, all right? So it's easy to graph that. Okay, so if I graph it, I would simply have to graph. Let's see. I gotta have access to the values because I don't remember what they are. So let me open it up in another page here. Okay, so your first value. So you have x values there. You have 0, 1, 2, 3, 4, and 5, right? And then you have 68%, so 10, 20, 30, 40, 50, 60, 70. And just graph it. So for 0, I got 0.68. For 1, I got 0.17. For 2, I got 0.10. For 3, I got 0.03, so really tiny. For 4, 0.01, so really tiny. And the same thing for 5. And you can see that it's skewed to the right. Okay, so clearly from this you can tell it's skewed to the right. But like I said, another way to tell is to look at the median, compare that to the mean. All right, so in this case, what we're going to say, we're just going to talk about the shape. So in this case, the distribution is skewed right with a mean of 0.55 and a standard deviation of 0.973. All right, and that's it. That's all we're looking for. So let's look at the next question. All right, so many babies develop irregularities in their skull shape and require a corrective helmet. When determining if a baby will need a helmet, many measurements are taken including head circumference. For 4-month-old babies, the distribution of head circumference is roughly symmetric with a mean of 15.65 and a standard deviation of 0.41. The head circumference of a baby is expected to increase by 2 centimeters each month. Specialists in infant helmets would like to create a new distribution predicting the head circumference in babies for babies that are 5 months old. To do this, he transformed the distribution using the following expression. All right, so we got a transformation. So multiplication and then adding 2. So the plus 2 is for the increase of 2 each month. The 2.54 is to basically convert it from inches to centimeters, so 2.54. So what is the shape of the transformed distribution? If we multiply or divide or add or subtract, it doesn't change the shape. Okay, so these transformations do not change shape. As long as you don't multiply by a negative number or divide by a negative number, then you should be okay as far as shape. So the shape doesn't change. Therefore, and now if you look at here, it says if you look at the measurements, it says it's roughly symmetric. Okay, so that means that the shape of the new distribution is also roughly symmetric. Okay, so what is the mean of the transformed distribution? Okay, so now if we want to find the mean of this, I'll just do it over here. So let's say that this distribution is let's say x is the head circumference, right? And so y is 2.54 times x plus 2, right? So if I want to find the mean of this distribution, this is capital Y, and I need to do the mean of this, right? Remember, addition does not, or addition changes the mean by adding 2 to it, right? So we're 2 plus, and then multiplying by 2.54 also affects the mean. So it looks like this, right? And we know that the mean for the babies is 15.65 inches. So we just have to do this. It was 15.65, sorry. Okay. Let's figure out what that is. So 2 plus 2.54 times 15.65. So 41. 0.75 centimeters. Okay, so there you go. So there's your mean of the transformed distribution. The standard deviation The standard deviation of y is equal to the standard deviation of 2.54x plus 2. Now, 2 doesn't do anything to the standard deviation. It's just going to be that. It's 2.54 times. So we multiply by 2.54 times the standard deviation for the babies. It's 0.41. So about 1.04 centimeters. Okay, so those are your two answers for number 7. All right, and then we're wrapping up with the last question. So the distribution of the cost of utility bills for the month of July for households in a certain city in Florida is approximately normal with a mean of 469 and a standard deviation of 58. Let J equals the cost of the July utility bills for a randomly selected household in the city. Find the probability that a randomly selected household has July utility bills costing at least $450. Okay, so again, this is a normal distribution, so I'm just gonna try to draw out the distribution here. The mean is 469, and then the standard deviation is 58. So I'm gonna continue to add 58 to that. Okay, just to show my work here. All right, and then I'm going to subtract. Okay, and then we want, it says at least 450, so it's got 450 or higher. So we got 450 is right around here. We want it to be at least, so it's going to be greater than or equal to. All right, so now, so the probability that the cost, that J, is greater than or equal to 450 is equal to 1 minus. Now, remember, we're going to use the table to convert this to a z-score, and then we're going to subtract it from 1 to get the area to the right, because the table gives you the area to the left. So we're going to calculate the z-score. Remember, the z-score is the value minus the mean. So the value is 450 minus the mean of 469 divided by the standard deviation of 58. So let's do that over here. So negative 0.33. You want to round it to 2 decimals. All right, so then we go to our table, negative 0.33. Okay, 3. So 0.3707. So 3707, and then subtract that from 1. All right, so you get 0.6293. All right, so that's the probability. So it's going to be around there. Of course, if you use normal CDF, then you would get a different answer. Again, remember, lower limit is 450. The upper limit is a really big number, 10 to the 9th. The mean is 469. The standard deviation is 58. And so you can use that when you do normal CDF on the calculator. All right, it says for the same city, the distribution of the cost of utility bills for the month of August is approximately normal, with a mean of 498 and a standard deviation of 73. Let A equals the cost of August utility bills for a randomly selected household. Assuming J and A are independent, find the mean and standard deviation of the distribution of J plus A. Okay, so the mean of j plus a is just going to be simply the mean of j plus the mean of a. All right, so it's going to be the mean of j, we said was 469. The mean for a is 498. So we simply have to add those together. So we get $967. Okay, so this is the mean. And then the standard deviation, we can do it over here. The standard deviation of j plus a is the square root of the sum of the variances, j plus a. Okay, and then which is the square root. Remember, it's a Pythagorean sum when it comes to the standard deviation. Okay, so the standard deviation for j was 58, so 58 squared and plus 73 squared. Okay, let's see what that is. So 93.24. So $93.24. Okay, so there's your standard deviation and mean. Find the probability of randomly selecting a household in the city with a combined utility cost for the months of July and August that is less than $800. So that's going to be this distribution with this mean and this standard deviation, okay? So this is going to be j plus a, okay? The total for that. So j plus a is 967, and the standard deviation is 93.24. So I'm just showing my work here, okay? So 967 plus 93.24. $1,060.24, $1,153.48, and then $1,246.72, and then we'll subtract okay. All right, so that's the new normal distribution for j plus a, and then we want a combined utility cost of less than $800. So it's going to be around here for $800, and we want it to be less than that, the area to the left. Okay, and we'll say that t is equal to j plus a. So then the probability that the t is less than $800 is equal to, and then we can look up the probability. So convert this to a z-score. So 800 minus the mean divided by the standard deviation, which is 93.24. Negative 167 divided by 93.24, so negative 1.79. All right, and then we're going to look this up on the table, of course, negative 1.79. Negative 1.79, which gives us 0.367. So 0.367. Okay. All right. So then, yep. So this is the area, 0.0367. So that's the probability of getting less than 800. The combined of getting less than $800. All right, so that's one way to do it. I'm going to show you how to do this using the calculator, because now this time what we're going to do is the upper limit is 800. The lower limit is basically negative infinity. So we're going to do like a really, really small number. Like, for example, like a really, really small number, like really like 0 or something like that. So 10 to the negative 9 or something like that. Something that's really small, like close to 0. And we'll do this on the calculator to see if we get that same answer. It should be really close to that answer. Oh, also you don't have to make this really close to 0. If you want, you can actually make this really, really negative, like negative 10 to the 9th power. So like negative 1 and then 9 zeros. So that's actually going to make it even more accurate. But either way, it should be pretty similar to the answer, as long as you get really, really a number that's really, really far to the left. Okay, so let's go ahead and do this. So we got second vars, go to normal CDF, and then we got, okay, really, really negative number. You got 800 for the upper limit. 967 for the mean, 93.24 for the standard deviation, and there you go, 0.0366. Let's go back and let's change this value so you can kind of see. Okay, so negative 10 to the 9th. Let's see what it is if I put 10 to the negative 9th power. That means a number really close to 0. Okay. Let's see what that turns into. Since that's really far. Oh, I didn't mean to do that. Let me put that back there. Okay, so now let's see. You still see you get still 0.0366. The reason being is that it's really doesn't make that much a difference as long as this number is really, really small, enough for you to get it to be accurate between that many decimals. All right, guys, that's going to do it for the video. Hope you found this useful and informative as usual. I'll see you in the next one.